So today in Unit 2, Day 3, we also talked about symmetry. There are three types of symmetry when it comes to transformations. They are line symmetry. That is when you can wrap a figure onto itself in reflecting in a line. So for example, right here, if I have a vertical line through that triangle, then we can see that each side of the triangle matches up. So therefore, that figure has line symmetry. So line symmetry is when you can reflect across a line. Point symmetry is when a figure looks exactly the same when it is upside down. So a 180-degree rotation. So take this capital N. If I rotate my paper completely upside down, it still looks like a capital N. Rotational symmetry is any symmetry that maps onto itself in a less than 360-degree rotation. So if I just take this star or sun, whatever it is, and I just move it that way just a little bit, rotate it that way just a little bit, I can see it maps onto the original figure. Also, something important to note is what I have highlighted right there. If an object has point symmetry, then it also will have rotational symmetry. So basically, we're just going to see a bunch of examples of different types of symmetry. So first of all, this is a regular hexagon. Notice if I take a line and draw it right there, it matches up on both sides. Therefore, this figure has line symmetry. And it looks exactly the same upside down, so therefore it has point symmetry. And if it has point symmetry, then it also has rotational symmetry. Number 2 is a triangle. So we already saw an example of this. If I draw a line straight through the center of the triangle, which mine wasn't straight, but if I were to, it does match up on both sides. Therefore, we do have line symmetry. Also, upside down, it would actually look more like this with the vertex that's on the top pointing down. Therefore, it does not have point symmetry. So point symmetry means it looks exactly in the same orientation when it's upside down. However, if I take it and rotate it just a little bit that way, I do match up to the original figure. So therefore, we do have rotational. So you can have rotational symmetry without having point symmetry, but you cannot have point symmetry without having rotational. All right, number 3 is a parallelogram. It does not have line symmetry because nowhere that I draw a line does it match up on both sides. Okay, so because this corner would be coming down here and this one would be going up there. So those do not match up. All right, so it does not have any type of line symmetry. Upside down, it looks exactly the same because right now it kind of looks like the state of Tennessee where you have a bottom corner on the left, top corner on the right. So it does have point symmetry. And if it has point symmetry, it also has rotational symmetry. Number 4 is a picture of a right triangle. There is no line symmetry because I can't draw a line anywhere and it match up. Point symmetry, it does not look the same upside down, nor does it have rotational symmetry. So number 4, the answer is none. Number 5 is this 5-pointed star. I can draw a line through the center vertically of that star, and it matches up on both sides. So that does have line symmetry. Also, upside down, that top point would be pointed down, and these two bottom points would be pointed up. So it does not have point symmetry. However, I can rotate it just a little bit to the left, and it would match up. So it does have rotational. So that star has line and rotational symmetry. Number 6 is kind of an odd figure. I can draw a line anywhere on this, and they do not match up on either side. So this does not have any type of line symmetry. Upside down, though, it does look the same. So it does have point symmetry, and it also has rotational symmetry if it has point symmetry. Number 7 is a capital A. Number 7 does have line symmetry because if I draw a line vertically through the center, it matches up on both sides. It does not look the same upside down, so it does not have point, nor does it have any other rotational symmetry. So number 7 only has line symmetry. Number 8, it does not have line symmetry. I can't draw a line anywhere on that figure and it match up on both sides. It doesn't look the same upside down, nor does it look the same any way I rotate it without going completely around. So this has no symmetry. Number 9, it looks like a pinwheel. And let's just see. Number 9 does not have line symmetry. However, it does look exactly the same upside down, so it has point, and it also has rotational. Number 10. Number 10 does have line symmetry. There's a couple places I can draw lines and it look the same on both sides. It does look the same upside down, so it has point symmetry. Also, since it has point symmetry, we know it has rotational symmetry. Number 11, capital R, does not have line symmetry or rotational or point, so it is none of those. Number 12 is a quadrilateral. This is actually called a kite because the two sides are congruent or adjacent, and two adjacent sides are congruent as well. If I draw a line through the center vertically, I do have line symmetry. It does not look the same on both sides, so it does not have point symmetry. Same with rotational. So line is the only symmetry number 12 has. Number 13, it does have line symmetry because I can draw a line straight through the center there and it matches up on both sides. However, it does not look the same upside down because it has a point pointing up. Now upside down it does not, so it does not have point symmetry, but if I rotate it just a little bit in that direction, it does match up, so I do have rotational symmetry. Number 14 is a capital Z. It does not have line symmetry. Can't draw a line anywhere and it match up. It does look the same upside down, so this one has point symmetry, and since it has point, it also has rotational. All right, in class, I'll let these be the you try problems. So if you want to, pause the video, and then you can try them on their own, and I will go ahead and answer these so that you can check your work.
You still recording?
It's okay. All right, that's the end of notes for today.